Okay, good morning, everyone, and good evening or good afternoon, wherever you are. Welcome to the Bloomberg Intelligence webinar on DeepSeek's impact to the LLM race. As you know, over the weekend, we had this amazing paper that was released from DeepSeek outlining, how they train their model and how they are deploying their model. And that had huge ramifications in terms of, what it means to the companies that are training their models, the downstream impact to the chip makers and the semi-cap players. And that's why we organized this three-part webinar series. The first webinar took place last night here in the US, where we went over some of the impact. Today, we are going to talk about the Asia focus aspect and the impact of it. And we have Rob Lee, who authored this China AI deep dive, where he has talked extensively about DeepSeek prior to this paper. And then we have Kunjan Sobhani, who's going to talk about the impact to the chip makers like NVIDIA and Broadcom. We're joined by Masahiro Wakasugi, who will talk about the impact to the semi-cap equipment players. And Anurag was there with me last night in the US webinar, where we will cover the hyperscalers, and Rob Schiffman is going to provide the credit perspective. So with that, housekeeping, a couple of items. Please add your questions in the Q&A box. We would like to make this as conversational and interactive as possible. We really want to get to as many questions you have, given the last 48 hours of development, and I'm sure there are a lot of ambiguities and question marks around this topic. So we'll try and address to the best of our ability. And with that, I'm going to hand it over to Rob Lee, who is going to start with the China AI perspective. Rob?
Thanks very much, Mandeep, and good afternoon, good morning, or wherever you are in the world. Thanks for joining the webinar. So as Mandeep says, I'm one of the technology analysts based in BI's Hong Kong office. I'm primarily focused on the China tech space, particularly companies such as Tencent and Baidu, with a core focus really on AI and cloud computing, as well as the internet platforms out here. So rather than rerun through the many headlines that have been on DeepSeek, I'm sure anybody joining this webinar is already familiar with that and gone through, and there's no value in me repeating all of that. I just wanted to give some sort of context and background and give you a better understanding of our view as to why we think China is actually very well placed, really is closing the technological gap with the US at a fairly rapid rate, and what are the primary reasons for that. And obviously, DeepSeek is the emerging poster child, if you like, of the Chinese developments. As Mandeep said in his intro, we've actually been following this company, one of many companies we follow both in the listed markets and private equity space for 7 months or so, and we've been writing on it extensively over that period. So just taking a step back from DeepSeek at the moment, this exhibit gives you a very small snapshot of the huge number of large language models there are in the Chinese market at the moment. And as I said, we are strongly of the view that China is definitely strongly placed behind the US as the main contender, because how many European, Japanese, or German model companies can you name? Very few. There was a potential major roadblock placed for Chinese companies as a result of the export restrictions we saw on NVIDIA AI accelerator chips. But as any good engineer would do, Chinese has got a strong track record, I think, on cost down, and they've worked around the problem. So those chip shortages have been averted to a large degree. There's been some preemptive stock building by the large tech platforms like Alibaba and Tencent before those controls came into effect. So they've built up buffer stocks that has enabled to keep their developments on track. But again, like any problem in life, you've got to work around it. So the way that the industry is increasingly developing in China, again, as highlighted by DeepSeek, is a move towards smaller, more efficient, more focused models that are less computationally intensive and have the added advantage of obviously being cheaper to both develop and run, as I said, as highlighted by DeepSeek. I would also say, without trivializing it, relative to maybe semiconductors, where chips are made at the bleeding edge, at the cutting edge of physics, the technical barriers to entry on the software side are relatively lower. And again, that has been to China's advantage because China is one of the major players globally on the software stage. So this is a slide from our deep dive that was published at the end of the year, just looking at some key metrics across some of the models. So DeepSeek's version 2 model, which has since been superseded very recently by version 3. Again, just going on some of the headline metrics there, is very efficient, primarily because it is based on something called mixture of experts. So when the model is actually activated, rather than activating the entire model at one time to answer a particular question or a problem, only the relevant part of the model is activated. So you can see in this table here, of a total number of 236 billion parameters, only around 10% of those are activated at any one time, which gives you huge computational efficiencies and therefore cost savings as well. And that is part of their secret sauce. There's a lot more to it than that. And with the latest R1 version that's come through with quite enhanced feedback mechanisms, has improved the accuracy of their results, which, as we'll come on to in a minute, if we just move on to the next slide, please. We'll come on to that point in a second, but China is, I think most of the people on this webinar are aware, Chinese LLMs are ranking well on global benchmarking services, tables, I should say, with DeepSeek most recently ranking number 2 on the LiveBench benchmarking service. So again, just to give you an idea of the very rapid progress that China's made in LLMs, how many LLMs could any of us have named in China or from the Asian region in general when ChatGPT was announced? I mean, next to none. And again, reflecting or due to their inherent key technical strengths in software development, benefiting from the relative lower technical barriers to entry. So we just go back to the other slide, please, a second. There were 14 certified large language models in China in October 2023, and that increased to over or close to 200 in July the following year, and now we're at a total of 300 at the end of 2024. So that gives an illustration of the very rapid progress they've made. Okay, let's move to the next slide, please. So again, one of the reasons that China has made rapid progress in this area is because of the numerical advantage they've got in software developers, an approximate 3-2 numerical advantage over the US, for example. And as I've explained, those export bans and the semiconductor bottleneck has been largely averted. And as a result of 2 of those, and with a focus on innovation and moving to smaller, more efficient, low-cost models, that's enabled their developments to progress relatively unhindered. Let's move to the next slide, please. So this is a snapshot from our deep dive report in June of last year. Highlights in orange some of the key Chinese names. This is data from a provider called LiveBench, which is a US independent benchmarking service for large language models. So as of June last year, DeepSeek was ranked as number 7 globally. And on their latest data, as I mentioned earlier, DeepSeek has actually risen up the ranks and is now ranked number 2. Alibaba at this point in time was the only large tech platform that was ranked in the top 15. And to be fair, though, whilst DeepSeek is the company that is making all the headlines at the moment, this list is still dominated by US names. So move to the next slide, please. I finished. I think that gives you hopefully a reasonable understanding of
Rob,
what's been going on.
can I jump in here? So
Sure.
clearly, what you just showed is there are a lot of LLM players in China, but what really struck a chord with everyone here was the fact that this company DeepSeek trained their model on 2000 odd GPUs, and the total cost was $6 million. Do you buy into that? Is there a catch here that everyone should be looking at in terms of their recurring costs?
Now, first of all, I think it's been mentioned, DeepSeek did publish a paper. In fact, it's published several papers. On appearance, they have the appearance of an academic paper, but they're not. They're not peer reviewed. They're not independent. Now, I do think that they're largely based in fact, and the results speak for themselves in terms of the results from these external benchmarking services. However, and I think to probably everyone on the call, it just intuitively is this company really developed this thing at a cost of less than or trained at a cost of less than $6 million? It feels hard to believe. Although there is some detail on the paper as to how they've gone about that, I think just intuitively it doesn't make a lot of sense. That said, there is plenty of evidence, and the fact they've open sourced their model, and if you like, in crude terms, allowed people to poke around in the nuts and bolts. This is an innovative Chinese company, and China, as a general point across the tech sector as a whole, has got a fantastic track record on cost down. So I think what we're seeing is real, but whether the numbers stack up exactly, I don't know.
And the other dimension to this is the data. Do you have a sense of the data that they have used in their model, which is a different corpus from, let's say, what OpenAI and Anthropic have used?
Okay, that's a absolutely great question. As you know, on all these models, rubbish in, rubbish out, you're only as good as the depth and the quality of your data. I think the quick answer to that is we don't know. But the issue for the Chinese developers of large language models is their access to English language data, because something like 80 to 90% of all the information on the global World Wide Web is in English. So I think, again, with tests that have been done to compare Chinese models to Western developed models, Chinese models, unsurprisingly, win out when it comes to questions relating to Chinese history, culture, something that is relevant to this region. But they tend to do less well on other topics, and obviously they have to operate within the censorship restrictions that are prevalent in this part of the world. So I think the access to data and quality, depth of data is a potential issue for these companies going forward. And whether President Trump or others, as a result of what's going on here, take steps to restrict their access to that data, that is one thing that could potentially happen. So I think we'll have to watch that space.
Yeah, and really quickly before we segue into the semis impact, do you think there was a big leap in terms of the improvement you saw from their V2 version to V3 and R1? And if yes, what is it that everyone really is focusing on now versus where they were probably in version 2 and version 1?
Okay, I would say in terms of technical performance, yeah, it's more iterative. So version 3 to version 2, they're making good and steady progress. But in terms of the relative rankings on the benchmarks, they have been rising. But again, that's more iterative. R1, as you know, is a reasoning-based model with some additional feedback mechanism based into it. That is innovative to some degree, but there are plenty of reasoning models out there. But I think the thing that's really caught people's eyes is really their claims on the costs, on the training costs, and they are spectacular if they're true. Again, I think they're based in some sort of truth, but I can't believe the numbers are quite that low. But this is a highly innovative Chinese LLM, which is giving the main competition, primarily in the US, a good run for its money. I think we can safely say that.
Thank you, Rob. And if you have a question, please add it to the chat. We'll try to get to as many as we can. With that, let's move to semis, and I'll pass it on to Kunjan Sobhani. Kunjan?
Thanks, Mandeep. We can move on to the next slide. So as most of you are already thinking about this, but one of the top questions I've been getting from investors since the weekend is, does this new approach reduce the need for the GPUs or the number of GPUs? And it's a very debated topic right now, and we have tried to break this down step by step based on workload and customer type in our note. So starting with training, the results of this approach definitely have presented a strong proof point that similar model training results can be achieved for training using smaller clusters of GPUs and even without using the most high-end GPUs. And this does question the projections for the 1 million GPU type clusters and the spending on it going forward. And we believe there is some merit to this hypothesis, and that the US hyperscalers will consider such efficiency options. However, we don't think this is just like turning off a switch. We still think the CapEx plans around compute chips overall, especially accelerators and related networking chips for 25 and at least first half 26 still remains mostly intact, as these programs and outlays are not as nimble as people think to move around. And having a best-in-class AI infrastructure for top hyperscalers is still a priority amongst them, which they have announced with their increased CapExes, and which we think they'll continue pursuing at least in the near term. Secondly, when we actually think about inference, so the DeepSeek approach actually moves a lot more compute burden on inference. What I mean is, in order to generate a very low latency, and the keyword here is very low latency, because that is what really enables consumer level monetization from inference at scale. You need a lot more GPUs, a lot more amount of GPUs than were used for training this specific model. So you can argue that a wider scale adoption of this approach, when moving to wider scale inference, will require a lot more compute. And to bring this back together, even if we assume the hypothesis that the need for GPUs for training will drastically decrease, we think a wider scale adoption for inference and the increase in the efficiency that this approach provides will drive the demand for compute overall still higher. So what I mean is, you might see that the current AI winners might not be the current AI winners 2 years from now. You might see a share shift with AI chip players more at the edge, gaining a lot more share of the overall AI wallet. But we don't think this in any ways reduces the demand for overall compute, whether it being accelerators or networking.
Can I interject here, Kunjan? So obviously everyone is looking forward to the Blackwell release from NVIDIA. And a lot of the hypothesis there was centered around the fact that you need to build the next 1 million cluster of GPUs to train the next version of the model, whether it was GPT-5 or the next version of Claude. How does this breakthrough really change, how NVIDIA or someone else would be thinking around the scaling laws?
Yeah, like I said, that 1 million GPU cluster hypothesis does come into question with this approach, but it's more nuanced than it's straightforward. So if you look into how the model was trained, they used a lot of open source models and agents, right, or experts, which were already trained by someone. So the someone that really created that model from scratch did use a pretty large amount of NVIDIA's GPUs. So, we still assume that the largest, or at least handful of those hyperscalers, will still work on creating the next bigger and more advanced model from scratch, which still will require a lot more GPUs for training. So it's not just, like I said, turning off a switch, but it does bring into question. And I think eventually, as hyperscalers think about their next layouts and next outlays, they are going to reconsider the amount of clusters they need in the GPUs, because there's also this approach also sort of provides an alternative proof point that you can still get similar results with a much smaller clusters which are more distributed. So this also impacts sort of networking that goes around with the GPUs in these clusters.
Got it. Thank you.
We can move on to the next slide. Yeah, so another question I'm getting is like, how does this impact the ASICs? Again, this is a bit more nuanced. Like I said, this approach puts a lot more burden for compute on inference when you think about running inference from a model which is trained in this manner at scale with low latency. And a lot of desire points for ASICs are that it delivers much better cost when it comes to inference. So in a way, depending on the use case and depending on the customer, it actually makes a bullish case that ASICs would become even much more prevalent than we thought earlier, especially when we are using to inference. Now, why I say depends is, again, when you think about Google and the way it uses GPUs and the margin profiles there versus Amazon and the way it uses its inference chips, I think you have to go case by case, where in one case like TPUs, there might be some concern on the current TPUs that Broadcom has been supplying to them, which were much more focused on the high-end training. There might be less need for them versus when you look at the accelerators specifically designed for inference on Amazon, you might argue that the need for those is going to actually increase even further. So based on case by case and what the application is, ASICs in certain areas could see a much more boost versus other areas could see some kind of headwinds. Next slide, please.
Actually,
Finally, there's
Kunjan, before you go to geopolitical aspects, what about the impact on Broadcom and Marvell? I mean, since you mentioned ASICs, and Broadcom recently gave its guide, the service addressable market of 60 to 90 billion, if I remember correctly. How does this breakthrough impact someone like a Broadcom or Marvell?
Yeah, exactly. So, in the ASIC bucket, both Broadcom and Marvell are the design partners for both chips for ASICs for training as well as inference, right? Training is a larger portion of their revenue base right now, especially Broadcom's, given the TPUs at Google. So if we believe that this approach will radically change, we use accelerators for training, i.e. cut down the need for high-end accelerators and the need for larger and larger clusters, this could definitely be a headwind to that ASIC training portion of the revenue. However, if this does help the inference side of things, that revenue can be offset both for Broadcom and Marvell by them supplying more chips for inference to these same customers. Now, one thing to point out is the inference chips do have lower ASP per chip, so you need a lot more volume to offset the similar revenue base and also slightly lower margin profile.
Yeah, and especially if you were using a brute force approach, which all of these model companies were. I mean, the way these algorithms were run, it was just brute force through, billions of parameters. Now, as Rob mentioned, it's more of a mixture of expert going to the right set of tokens based on the type of query. So how would the chip guys look at it from a design perspective? Because it sounded like with Blackwell and Hopper, it was more about how can we scale the chip to package more flops and run it in a connected fashion. Does that change anything for the ASIC guys in terms of moving away from brute force to more of a mixture of experts approach?
Yeah, I mean, it doesn't change for the ASIC chip guys approach. It depends more on based on if this approach is adopted by LLM creators, right? The type of ASICs that will be more desirable. Current approach, like with the Blackwell systems, is connecting as many GPUs together with access to as much memory as possible so that they all function as well as one, and also connecting a lot more stronger networking, much more high bandwidth networking for all of them to act as one. This approach sort of challenges that thesis that you don't need a lot more GPUs with a lot more memory to act as one. So again, the chip types, especially for the ASIC chip types and the needs for those could change. And but again, we think there's an offset where the chip type could shift from one chip type to another chip type. So like I said, the current AI winner chip might not be the next AI winner there, but it definitely does not reduce the compute needed for this approach.
I mean, it sounded like on the inference side, there are a lot more vendors, Samba Nova, Cerebras. Does this breakthrough make their offerings more attractive in terms of using those chips as an inferencing option?
Not at this point, because again, the race to scale is still of priority, at least in the US hyperscaler. So if you really wanted to shift your strategy with this approach, but still have a viable solution, which is get ready from day one, you would still really go to like the likes of NVIDIA and AMD on the merchant side, and the likes of Broadcom and Marvell on the ASIC side.
And lastly, since you're on this topic, do you think companies could be looking to use CPUs now for inferencing, or it's still GPU centric when it comes to both training and inferencing?
At least from the results and from the DeepSeek papers, it definitely still, we think GPU still will be the primary vehicle when it comes to inferencing. Because again, when you look at the amount of latency it's taking for their low count GPUs to inference that model, it's ridiculously high. So if you really wanted to reduce that latency, GPUs would still be the best vehicle to get that.
Okay, thank you.
We can move on to the next final slide. Yeah, so we also wanted to touch upon the geopolitical impact or probable impacts without sort of speculating. So, on the plus side, if this approach changes, right, we said more compute will definitely be needed. The chip types might shift, but definitely a lot more compute will be needed for inference. So, which is a positive. Secondly, there's this theory that the US hyperscalers would even get much more aggressive in terms of their capex plans or hardware deployments now based on this results, which again is positive for the chip players, which are all heavily US based in our coverage. The negative from this would be if US, the new administration's comebacks with much more stronger retaliatory sanctions, because the assumption is, this models were built based on H800. So even H800s are even powerful, and we should restrict the flow of such chips as well. This could be another headwind especially to NVIDIA for the China revenue. However, there's, like I said, there could be offsetting effect if the US hyperscalers urgency increases and they could just purchase more NVIDIA GPUs for inference or training, offsetting that loss to China.
And Kunjan, there are a few questions on the chat. I'll try to get to at least a couple now with you and then come back later. So any comments on how this changes the power requirements for training or inferencing?
Yeah, so if you go with this approach, and again, that if this is all based on this hypothesis that everyone is going to adopt this new approach, you don't need a lot more bigger clusters, like I mentioned, right? So a lot of these power issues, especially liquid cooling needs, come when you are trying to attach all of these GPUs to make them function as one. If you distribute the clusters and run into smaller and medium-sized clusters, the power needs are much more manageable. You can easily get away without liquid cooling, and you can have distributed sort of compute within the data centers and even across the data centers. So definitely reduces the bar for power as we are thinking the power needs of a system like a Blackwell system. And I'm sure Woojin can add much more on the power side as well.
Yeah. And then another one in terms of, the use of their chips for training. So they showed how, they use a certain number of NVIDIA GPUs. I don't think it was the latest Hopper GPUs, but if they were to use the latest ones, the H800s in their cloud, do you think that would have shrunk the time taken for training their model in this case, given all else being equal?
Absolutely. I mean, in their papers, if you read the technical details, right, the reason they had to create this optimized approach were twofold. One, they didn't have access to someone like an H100, which has much more higher memory and bandwidth, which even the H800s don't have. They're clocked similarly, but have lesser memory access. So to bypass that, they had to come up with this new approach. And also, they did not use CUDA. They used even a low chip level RTX language. So if they had access to a much more advanced NVIDIA GPU with CUDA software ecosystem, it would have taken them much less time.
Very interesting.
And you can argue that they might not even have tried to come up with this approach and would not have gotten these results.
Yeah, amazing. I mean, there are a lot of questions on the chat. Please keep them coming. We'll try to get to as many as we can. With that, I'm going to hand it over to Masahiro, who's going to talk about the semi-cap equipment impact. Masa?
Okay. Next slide, please. Yes, I am covering chip making equipment as well as some memory companies based in Asia. And the first of all, we'd like to highlight that because of the maybe low cost and more higher efficient LLMs, would promote the more adoption of the AI for the end users, which should be good for the chip market. And when we think about the chip equipment market, we should think about a total chip market in, say, on the long term and the mid-term, short term. So in this case, we think that maybe is still a chip market in 2030 could achieve 1 trillion US dollars. And because probably the AI usage should increase going forward, and end users will adopt more AI, and maybe currently some AI functionality may be quite expensive. So and if we can use more AI functionality at the lower cost going forward, that should create more demand for AI as well as semiconductors. So in that case, as long as we still we can keep the 1 trillion US dollars chip market in 2030, in that case maybe capital spending for the semiconductors should be quite strong. So we are expecting some kind of around the 25% range capital intensity. So in that case, in the long term basis, we think that maybe the chip making equipment market should be nicely growing going forward. And having said that, if we look at the right hand chart, we may have some kind of slowdown in the maybe the 2026 or 7. Probably hyperscalers will keep the 2025 capex. In that sense, as far as SK Hynix is concerned, their capacity for HBM is sold out in 2025, and probably for a while they could run 100% utilization rate. That should be pretty much clear. But after that, we may see some kind of growth deceleration because of that kind of more efficient LLM emergence. So in that case, we may see some kind of slowdown of the HBM demand going forward.
Hey,
And
Masa, can I
okay,
interject you on
all
that
right.
HBM demand? So I'll ask you the same question that I asked Kunjan. If, there is a change in dynamics in training versus inferencing because of this breakthrough, how does it impact the HBM demand if the market will get more skewed towards inferencing going forward, and these companies have to spend less on training?
Okay, so my simple answer should be probably HBM demand should exist going forward, even for the inference. Maybe the AI inference should be able to solve quite difficult questions and answer, and the latency should be very, very important when we use the AI inference, and maybe latency should matter quite a lot. In that case, HBM should be necessary. And maybe what we would like to highlight is that always the speed gap between CPU or GPU and DRAM or HBM is still, it's a big problem. So in that sense, maybe the very high-end DRAM or maybe could be HBM should be pretty much required going forward, even for the inference. This is my simple answer.
Yeah. And the other vector that I think we all are debating right now is if the inferencing moves from brute force to more mixture of experts and chain of thought reasoning, etc., does that impact the HBM demand in any way?
Actually, last week we had a pretty much deep discussion about mixture of expert with the NVIDIA guy in Japan, and we visited the office, and the mixture of experts should help we resolve the very difficult questions at less energy, or maybe in maybe with the low latency. So as far as I talk to GPU companies, we sense that these new software or new models should be pretty useful for the more difficult problem to be resolved going forward. So in that sense, I didn't feel very much about the demand deceleration for HBM, but we cannot rule out the possibility that we may not need the really most advanced HBM going forward. But in any case, we think that the latency should be very important for the calculation, regardless of the inference or training.
Got it. Thank you. Keep going with your slides, please.
Okay, so maybe I still think that the HBM demand is still pretty good going forward, but if we see some kind of demand shift from NVIDIA to some other, this is some kind of question we get from investors. So in that case, because HBM demand for NVIDIA is pretty much skewed to the SK Hynix. So if we look at the right-hand chart, SK Hynix HBM revenue already represent more than 40% of their DRAM revenue. So the mostly, that's coming from NVIDIA. So maybe that this is the kind of scenario analysis. So if the demand for NVIDIA related demand changes going forward, that could impact SK Hynix demand going forward. But maybe basically we think that NVIDIA related GPU demand should be pretty much strong going forward. Can you go to the next slide, please? So when we on the left-hand side, we show the advanced revenue and operating profit guidance. And last year, what we saw about their chip tester demand is that probably because of the very fast development of Blackwell and advanced GPU, and we have to assure the quality of GPU. And as you know that we experience some delay of the launch because of the quality issues. In this sense, we see that quite strong demand for chip testers at this point. And at this point, we are seeing a kind of 1-year cadence for the new GPU launch. So if we see that kind of deceleration, we might have that kind of demand deceleration for example, like chip testers. And as you can see in the left-hand side, we saw very rapid operating profit guidance revision for the upward, of course, and April or July or October. So because we did see very strong demand for the chip testers in last year, so going forward, there might be a possibility that we see some kind of deceleration of the demand for chip testers going forward. And regarding the that was about the GPU related or maybe accelerator related. And if we look at the HBM related demand, although we still think that the HBM long-term demand is pretty strong, but if we look at the what if HBM demand shifts to the standard DRAM? In that case, the difference of the production process between standard DRAM and HBM is kind of TSV related or back-end process. So we are showing on the right-hand side that which companies are involved with the kind of back-end process for the HBM production. So in this case, these companies might have some demand change going forward. So one scenario could be that demand may shift from SK Hynix away from SK Hynix to maybe Samsung, if we see the more demand coming from ASIC going forward. In that case, SK Hynix related chip making equipment makers, especially for the back-end process, could have some demand impact. So this kind of analysis should be quite important for the chip making equipment companies. So that's really about it for the chip making equipment side.
Great. Thank you, Masa-san. Next, we'll go to Rob Schiffman, who will provide a quick perspective on the impact on credit with this DeepSeek launch. Rob?
Sure. Thank you, everybody. No slides for me, and I'll try to be quick and maybe allay some fears. The fears in the credit markets yesterday were meaningfully less than in equities, and for good reason. But I would still say that my pessimistic world still has seen anxiety rise. If you look at spread movements across higher quality investment grade yesterday, we were only 3 to 10 beeps wider, with that risk skewed towards triple Bs. 3 to 10 beeps wider in a spread compressing environment where spreads are near historical tights are reasonably large moves, but in the absolute relative to double-digit equity declines and hundreds of billions of equity market cap loss, quite frankly, I see it as more of a rounding error. And the question really is that going to continue, and why were moves so small? And there's good reason. Tech credit is arguably the best position in its history. From a ratings perspective, highest ever, balance sheets, strongest ever, cash flows, records across the board. And a little bit, why is that? One is when you look across tech cumulatively, balance sheets are sitting on about $1 trillion of cash. $1 trillion of cash sitting on balance sheets ready to be deployed. If you look at the largest AI players, just from a credit perspective, Microsoft AAA, Apple AAA, Nvidia, Alphabet, Meta AA, Alibaba, Tencent single A, there is a tremendous amount of balance sheet flexibility that's built in. I don't see much reason, particularly after hearing our equity analysts say in the near term, we're unlikely to see any sort of significant spending changes being made, why you're going to see any real credit risk from a rating agency perspective or even a spread perspective based on current fears and questions. Now, the names that are most exposed, I think it's somewhat obvious to me, are the semiconductor designers and manufacturers, as well as triple B hardware manufacturers, Broadcom, Intel, Micron, Dell, HPE. The question for those names is really going to be, where is the growth going forward if spending is going to shift? Now, the interesting thing is what we're hearing is that there's still going to be a tremendous amount of spending. Maybe it's going to be a little bit lower, or maybe it's going to shift. But if it shifts away from this subsegment, those are already the lowest rated names. So those are the ones that I think you have to be most wary of right now. And if you think about it, if this spending model really changes, so the largest hyperscalers pull back dramatically on CapEx in, say, 27, 28, and you go from Microsoft spending 80 billion to only spending 40 billion, quite frankly, that's a positive from a credit perspective. If you cut CapEx, the biggest hyperscalers, by tens of billions, that just means there's tens of billions of excess dollars to do something else with. And maybe it's share buybacks, or maybe it's reinvest in other parts of the business or M&A. But I don't actually think that's a net negative. Maybe it does result in slower growth rates, but maybe it doesn't, and it just saves in CapEx. So my general sense is that overall for the investment grade tech market, there's little to no downgrade risk based on what we learned over the weekend. And I don't think there's any enhanced junk risk for any of the triple B names that we cover based on the information that we know. The cost of capital still remains very low. Funding needs across the board are also very low. If you dip down into high yield, where you would argue obviously there's always going to be the most type of exposure and volatility, there was really only one name in the tech index that lost a couple of points yesterday, and that was CommScope. But beyond that, it was really around the edges that we saw a little bit of weakness, but not big moves. And I'm not sure we're going to learn enough over the next day, week, or couple of months that's going to change that. I wouldn't be shocked to see sort of a slow grind wider after a multi-year period of nothing but spread tightening, but some sort of meaningful sell-off like we've seen in the equity market. I just think credit is positioned completely different. And happy to chat in detail or show some other slides that we've put together prior to this on the defensiveness of the space.
Great. Thanks, Rob. And
Got
I
it.
promise I'm going to spend a lot of time with questions. And so let's get to as many as we can. Kunjan, this one is for you. If we have a CapEx slowdown from the hyperscalers in 2026, which pocket do you think is more exposed, the GPU side or the custom ASIC side?
Yeah, so I'll answer this assuming this is very specific to the DeepSeek situation, right? And assuming that the fears coming out of this alternative approach come to fruition that quick in 2026. So what would get, I guess, the first most impacted would be the GPU side rather than the ASIC side. The ASIC programs are multi-year programs where these companies invest most of what they provide to the likes of Broadcom and Marvell through NRE at the beginning of the program. So it does not make sense for them to continue cut down this program. Even if they want to switch their strategy, they might reduce the unit volume. So it will impact on the per unit amount of money that these companies make, but it does not make for them to kill the programs. So the first one that would get impacted would be the GPUs.
Got it. And do you have a sense in terms of how far is China in terms of their AI chip development? Maybe you or Rob, anyone who wants to take that?
Yeah, we get very limited info in terms of the China AI chip guys, most of them not being public. But what we do get from our channel checks are there. So when you look at Huawei's offering, and I think the question I read was like, are they similar to A100? So I have seen benchmarks which would say that yes, they have capabilities similar to the Ampere series. I wouldn't say exactly A100, but a different version for China for the Ampere series. And in fact, you could argue that the lowest level Hopper series NVIDIA versions, they do also have comparable solutions in terms of merchant GPU from China. I'll let Rob add his.
Yeah, I'd say that's very fair, and I think is probably relatively well understood in the market. The biggest challenge that the Chinese foundries have at the moment, even though they had that sort of landmark development on 7 nanometer, is the yields. I mean, it's been a technical achievement, but the yields are, maybe down in the 20% range. It's not commercially viable at the moment. But I know Charles is on the call. Charles covers TSMC, so maybe he could chip in something there.
Yeah, Charles, and if you can also talk about how much does it change the CapEx plans for someone like TSMC who has been supply constrained on the CoWoS side. So if you can address that part as well.
Okay. Can you hear me?
Yeah.
Hey, thanks for the questions. First, let's talk about China's AI chip making progress. So far, what we can say is that, technically speaking, China do have the capability to produce the AI chip that has the similar performance as the A100. But the thing you have to notice is actually that for the China's most advanced AI chip, that will still be produced under the 7 nanometers. That's actually at least one generation behind TSMC, NVIDIA's A100. So that means actually the actual performance in the physical world, you'll be actually far behind the NVIDIA's chips, unless actually the Chinese data center doesn't care about the power efficiencies and other things that most Western data center will care. Just put it simple, yes, they can. And then about the impact of these DeepSeek emergence, how would that actually affect the CapEx in the TSMC? That's the largest chip maker, and it's actually CoWoS capacity is very critical for making many of today's AI chips. We will see that actually right now the CoWoS capacity will be set to double this year, and then could be actually double again in 2026. I think the most likely that the expansion in the longer future, that would be actually could be slowly down a bit, because in the future that people may not be so eager to get into the fastest GPU as much as we thought. But still, they still have to expand the capacity for the CoWoS, because CoWoS is not just for making NVIDIA's AI chips. It's also important for making the other ASIC chips. For example, Google, Amazon, these people's their custom AI chips are all depending on TSMC's CoWoS. That's a smaller packaging to do. So in this case, if we are seeing that there's a strong demand for the ASIC AI chip in the future, so TSMC's core is still very much needed for the future.
Okay, thanks, Charles. And Masa, this one is for you. So, how do you see the growth curve for EUV chip equipment, and what impact does it have on someone like ASML?
Thanks for the question. So basically, simply speaking, we think that the EUV demand should continue to grow going forward. And one thing we would like to highlight is that I think that the most advanced GPU chips are adopting that the one generation, behind the technology. So in that case, for ASML, probably their development may be targeting for the, of course, data center customers, but including smartphone customers like Apple or maybe AMD, or maybe could be Qualcomm could be the first makers which can adopt the most advanced technology node. In that sense, probably demand for the for example, high-end UV equipment should continue to grow going forward. So, and we have to bear in mind that we have many very difficult social problems which can be resolved by AI going forward. So even though we have seen very cost efficient or high performance LLMs made by some companies including DeepSeek, but we still have many problems to be resolved by AI models, and which can be enabled by the most advanced chips going forward. In that sense, I believe that high-end chip demand should grow going forward, so which should be good for the EUV demand on a long-term basis.
Great, thanks, Masa. And the other big discussion right now is around open source versus closed source. And it looks like open source is having its big moment here with DeepSeek release. So, Rob, what do you think this company DeepSeek or any other company that's thinking of open sourcing their model in China, what is their commercialization plan when it comes to monetizing their innovation here?
Right. As you're aware, we've sort of said and written a lot on this front, because at the end of the day, no matter what the technological progress these companies are making, they ultimately need to have have the prospect of generating a commercial return. I would say from a China context, actually, the company or the two companies that are in the lead domestically at the moment is not actually DeepSeek, because it's focused more on overseas markets. It's actually Alibaba and ByteDance. And ByteDance, again, for those of you who follow the China market closely, was really playing catch up. They were caught on the hop and are a long way behind. But again, reflecting relatively low barriers to entry and obviously a lot of capital poured into it, ByteDance has really come up the rankings considerably domestically. And the key differentiator, apart from the quality of their models and technology and the training, etc., is particularly Alibaba is going down the open source road. So at the end of the day, if you're making this free for, I guess it's the generic internet model, isn't it, Mandeep? You're looking to build out your user base, no matter what the cost, as long as you've got the capital to keep going. And then you can think about monetization another day. So you want to build out your user base, squeeze out the competition, gain some degree of market dominance, or at least critical mass, and then turn to monetization.
Can I interject there? So are these companies thinking of exposing their APIs? It looks like, some of the US platforms have already incorporated DeepSeek today, but I'm not sure if they are paying any license fee because it's open source.
Well, no, that's absolutely right. So, and I think again, for those who know the China market, the competitive dynamics compared to America or Europe are very different. The competition is cutthroat. The level of pricing where you do pay a price tends to be significantly lower. It's a volume game at the end of the day. And also, I would say the large language model sector, going back to my presentation, with over 300 models certified by the regulator at the moment, it's commoditized to some greater degree. It has those sorts of characteristics, very low barrier to entry, very low level of differentiation between different companies. It makes it incredibly difficult for companies to start charging for these services when the switching costs are so low, and it's so easy to go to and start using someone else's model because it's free. So I think until we get a consolidation or a shakeout in the industry, the challenge of monetization is going to remain with us, and ultimately, it's balance sheets and the strength of balance sheets which will determine the winners and losers. But very briefly, just on the startup front, there is still enough appetite domestically in China, but some other interesting startups like Jipu AI and Moonshot AI to be continuously funded. So going back to our deep dive or whatever, we think this consolidation is at least 18 to 24 months away. So the pain on the P&L is going to continue. So good progress on the technology front, full marks there. Are we anywhere close to monetizing or even breaking even, let alone a profit for any of the companies in China? Not on a medium-term timescale.
Yeah. Okay. Thanks, Rob. And Kunjan, this one is for you. So, given this development and the architectural change and focus on efficiency, does this help chip makers on the car manufacturing side or any even AI PCs? Does this help drive faster expansion and deployment of AI in those areas on the edge devices, so to say?
Yeah, it's a very good question. So again, if you are in the camp of a firm believer, basically, if you believe the bear case of this approach, that it significantly kills the demand for such an expensive compute. On the flip side, what you get in return is a much cheaper, much efficient, lower cost at scale inference. What that does, and a requirement of much less advanced compute to run this inference. What that does mean is it deploys inference at edge AI devices, which is your AI PCs, your AI smartphones, your automotive cars now. And that does help the chip makers, the compute and networking makers who provide chips for those edge device cases. So AI PC compute providers, AI phone compute providers, and car SoC providers. So the flip side does help them because that does boost the adoption of inference on those devices much quicker than we had thought before.
But what does it do to the pricing power of someone like NVIDIA or Broadcom or Marvell if that market was to turn out to be much bigger than what people thought?
Well, so Broadcom doesn't play in that market, so it doesn't really impact them. NVIDIA does play in the AI PC side and in the automotive side. And, like I said, the inference use case computes generally go at a slightly lower margin and much lower ASP. So you need to sell a lot more chips to get the sort of same amount of revenue versus a training, comparable training chipset. So that does impact that per ASP, per GPU, or per compute chip.
Yeah, look, guys, we are coming close to the top of the hour. We could keep going on and on, but as I said, this is a 3-part webinar series. I would encourage people to listen to our webinar last night here in the US that had a more software-centric focus, and this is a big theme. We'll have another power-specific webinar later today. And I would just encourage you guys to take a look at the China AI deep dive that Rob mentioned, as well as our global generative AI deep dive. And we are available for anyone to chat with if you have any further questions. But thank you all for joining, and have a good rest of your day.